Hello and welcome to part 2 of my introduction into mathematics into the movement of objects in the Trials Fusion track editor. Now, before you think, what the hell is all this, I'd like to explain what my goal was here and how I sort of achieved it and sort of will come into play. My goal was to make this car move just like it does in the 001 demo, which is from point A to point B at whatever speed I decided I wanted it at, but also to swerve left and right. Now, I'll do things a bit backwards here. I'm going to actually show you the motion that I've come up with. And I want to show a couple of things that I've changed. Now, it's just kind of like going on a sine wave oscillation. I didn't really explain that in my last video because there's a lot to take into account there with how you change things. But I have a separate linear count here. And if you're a programmer, I want you to think of this as a for next loop. So in the case of this is just to propel the car. This has nothing to do with the sine wave or anything like that. I start at 0 and 476 is the end. Now let's assume that's meters, and I tell it to take 30 seconds. If I change that to 15, the car's twice as fast. That does not affect the oscillation of the sine wave. That's just to get it to where it is. And I can show you that. Unfortunately, it doesn't give you a chance to show different colors, but I have the X position there tied into it. So if I get rid of that, you'll see that that green arrow disappears. And the car won't move now. Well, it'll move, but it won't go forward. So I can show you that. Very easy. Rather nice. And I've got a little bank on the car as well, and I'll show you how I did that. So it doesn't just oscillate up and down, but it actually turns slightly and banks slightly. But we'll put the motion back in, the XY motion, well, the X motion back in, by simply going to X, telling it I want to use this linear motion. That's it. That's all that does there. So we can sort of ignore that now because that's the speed we want to go and that's everything that we want to do. Now I have just the one sine wave again. And my linear is actually kind of interesting because I've decided to make it 3590 rather than 359. And that's because the combination of this and the time will dictate the oscillation and the frequency. And you have to imagine this in your head because unfortunately there's no way to draw it. It's a shame it doesn't actually draw it on for you, but I can show you that. If I go down to, for example, a small number and launch the car, like there, we get a very small, slow, maybe 1 or 2 cycles. And of course it goes off piste there, and if I go up to a high number, and I was at 3500, don't forget, so we'll go to say 7 or 8000 or 16,000. We get an equally slow one because we've gone all the way around. I've probably gone a bit high there. You have to think of circular numbers when the bigger the number does not mean a better sine wave or anything like that in these sorts of mathematics, because once you get past the first oscillation it's a repeat. And I'm trying to get it down. I went way too high there. All right. Oh, I'm at 8400. Yeah, right. Because eventually I'm going to put it back to 3590. So we'll sort of double it there. And it's just a slow... There is actually an arc there. Take my word for it. Anyway, we're going to put it back at 3500. Let's see what it... Just always experiment. It's still the same slow. What have I changed here? Hang on. If I put it back to 3500, is that right? Are we right in the middle of something? Like I say, you could be at the apex of a parabola and not know it mathematically. Well, I don't know it because I'm stupid, but it's the times 1000 that always gets me. I have to take that into account on top of what I'm doing. Hang on, it just goes, oh, you want to go this speed? Oh, let me just change that to you hugely. We're going to get it. Well, that'll do. Right, hopefully it'll be back to where it was. It is not. What did I change here? Did I change that? Oh, I might have changed that. I'm an idiot. There we go. As you can see, the car's actually turning. And I did that using exactly the same mathematics. And we'll have a look at that in a minute. I just doubled up on the yaw, which we were doing in the previous video, which is the rotation. And I actually had a different division for that here. And again, all I did was experiment with the numbers. I've got 82. If we change it down to, say, 60, and that's the sine divided, it may be more pronounced, and it is. I quite like that. It's like someone's turning the car. But I don't like the fact that it's not wide enough in the you know, in the bridge. It doesn't reach the edges of the bridge. So we're going to put this number up. Actually, let's take it down. When I made this video, I did actually practice this, and I had all these figures in my head, and unfortunately Heineken's killed them. Right, that's slow. Right. So we're going to go up hugely, which I think, let's go up to about 4. That's better. So again, I guess what this video shows more than anything is how easy it is to make the car do what you want, or whatever object it is. Whereas in the previous, you know, in the 001 demo, all it will do is go from A to B. And if you want it to do anything else, you'll have to manually set it to turn, manually set it to rotate. I'm not doing any of that. I'm just letting it, you know, do what the mathematics tells you. And if you had access to a programming language, you could get it to plot this out quite easily. Again, think of this as your for next loop, and everything that happens within that is going to be this mathematical equation. Unfortunately, with sine and any sort of loopable mathematical thing, you can't just give it a bigger number. You can't say 4i equals 1 to 1 million and expect it not to look exactly the same, because it will. Because once it's got that loop, it'll repeat unless you have something in it. When I do my Gallagher bit, and I intend to do that, I'm going to have it actually decay. So it'll start on a wide, kind of like this amount of movement, and then slowly go like this as it's going down, trying to, you know, emulate that view. But we can see the view of the car from the air because I've tied a camera into it. And that'll give you an idea of whether it's going the way you want. And the thing about this is, you might notice it's starting to float. And I believe this bridge isn't quite flat. I think it's at a slight angle. And that would be easily fixable, because I'd do one or two things. I'd lower the car, or I'd up the bridge. So let's try resuming editing. Because don't forget, this car's position is not being dictated by where I put it, so much as it is where the mathematics tells it, whereas the bridge doesn't have that worry. So if I move that bridge up a bit, try like to there, and then we test the track. We might have gone a bit high there. But then, in order to change the car's position, we would have to introduce an offset, which is always a good idea anyway in these sorts of things. Let's put it... Unfortunately, I have a slightly dodgy PlayStation 4 controller. Right. Hopefully that's in the right place. There we go. And now the car is travelling along the road, following a small sine wave pattern, turning and banking, although it's hard to tell. There we go. Oh, I didn't move that bit of the bridge. The bridge is in several pieces. And yeah, I hope this helps if you're into creating tracks, or into sort of making mathematical... Yeah, you can see where the bridge goes down there. Yeah, mathematical, interesting shapes and colours and sounds in programming. Once you grasp this, and every single system is going to be a little more tricky to use. This is frustrating. Anyone who's a programmer would be frustrated by this way of doing it. They could grasp it and then go, I just want to type it in. I don't want to have to move these icons and move numbers with the joystick, because I'm doing this on a PlayStation 4, not a PC. But it's still usable, and I love the fact that they've included this as an option in Trials. And just for laughs, let's move the camera to the other side and have a follow. Stay to about there. Let's see what that looks like. I mean, imagine putting headlights on the car and smoke effects and shaky cam. Oh, I need to come down a bit. And you've got yourself a really impressive looking track with just a few mathematical changes. Let's go to about there. I mean, we're getting to video. This is its own game now. Anyway, my name is Vinny Voodoo. I hope you've enjoyed this video. Look out for another one soon. I'll do something more interesting, hopefully. And thanks for watching.